Jai Hind, myself Ravindra Kumar from AKGEC Engineering College. I am AP in EN department, AKGEC Engineering College. Today I am presenting on the topic nodal analysis in the first unit, and the unit name is DC circuits. And this is covered under the subject of fundamentals of electrical engineering, for which the subject code is BEE 101, and it is intended for the students who are taking this course of fundamentals of electrical engineering in first year curriculum. So this will be useful for those students. So now first thing is, why do we use this nodal analysis? As we have seen in the previous discussions or previous lecture, we have taken the mesh analysis or loop analysis for solving a circuit. Similarly, nodal analysis, that is used for solving a circuit. Solving means to simplify the circuit. That means with the help of it, we can find voltage in any branch or current in any branch, or also we can find power in any branch by use of this nodal analysis method applied to any circuit. So this is the basic idea about this nodal analysis, that why do we use it, what is the purpose of this, so that we are using it in a circuit. So if we see it in the further coming slides, what are the various things in this. So if we see here, the topics which are to be discussed under this discussion, those are: number one, node voltage analysis, that we will discuss. This node voltage analysis, that is to be discussed under this. And then the super node analysis, that will also be discussed under this discussion today, that what is node voltage analysis, and then the super node analysis. So if we first see what is a node and what is meant by node voltage analysis. So if we see it, node voltage analysis, basically it is the application of KCL. KCL stands for Kirchhoff's current law. KCL is KCL stands for Kirchhoff's current law. So this is a node analysis, or say the node voltage analysis, that is basically the application of Kirchhoff's current law in a circuit, in a circuit, and that is basically on a node, which is also known as junction point. Now in this, what we do, one of the node in the given circuit, that is taken as reference node, and the other name associated with this is datum node or ground node. These are the different names for the same point: reference node, datum node or ground node. That we will see in the coming slide, that how do we take it or how do we select it. Then the next step is this reference node, or for which we call datum node or ground node, that is assumed to be at ground potential or zero potential, since ground potential is 0. So that's why this reference node, that is assumed to be at ground potential, which will be 0 potential due to it. Further, if we see what we do, the potentials of all the other nodes in the circuit, they are assumed or defined in reference to datum node or reference node. That means one of the node in the circuit, we select it as a reference node or datum node, and remaining nodes in the circuit, for those nodes, the potentials of those nodes, they are assumed or defined with respect to reference node. That is also the condition. Then finally what we do, we write KCL equations at different nodes, and then by solving those equations, we come to know the potentials of different nodes. And once we are able to find the potentials of different nodes, we can find the current in the branch, different branches, and we can find voltages across different branches, plus we can also find power in the branch, electrical power which is supplied to the branch, that can also be found with the help of it. So basic idea is, we are to apply Kirchhoff's current law on the different nodes in the circuit, and before that, first we assume a reference node, and with respect to that, the potentials of other nodes, they are taken, they are defined or they are assumed, and the ground node or datum node or reference node potential is taken as 0. So, that is the process for this node voltage analysis, or we can say these are the steps which are to be taken when solving the circuit using node voltage analysis method. So, if we see it, some example for this, like in this circuit, we see we are having this circuit in which this voltage source of 10 volt is there. This 10 volt voltage source that is there. This one with plus terminal is upside and minus terminal is downside. Then these different resistances 1 ohm, 2 ohm, 5 ohm, 10 ohm and this 2 ampere current source. These are the different elements which are connected in this circuit. So, now if we see we are to apply nodal analysis or node voltage analysis to this circuit. So, what we do? We can name these terminals, like suppose I write terminal names A, B, C, D, E, F, G and H. Now, after that we are to select reference node, for which we can say datum node or ground node also. So, if we see in this circuit the bottom line, that is EFGH, in this line all the terminals which are there on this line, they will be having same potential. Reason being, all the terminals are connected with help of a simple wire which is having negligible resistance, so that the on passage of current through this wire, voltage drop will be negligible small. That is why all the terminals in this line, bottom line EFGH, they will be of same potential or they will be of having same potential. So, we can assume it for convenience as a datum node or ground node. So, we take it as a ground node. This is the symbol for ground and this node becomes ground node or reference node. Or datum node. And now, with respect to this, the other nodes which are available in this circuit, for those nodes the potentials will be taken. Like if we see here, this terminal A, between in this branch AH, between terminal A and H, we have this 10 volt voltage source which is having positive plate upside and negative plate downside. Now, this negative plate is directly connected to H and H is at 0 potential, since this complete line that is having 0 potential, that already we have discussed why. So, this negative plate of the battery that comes out at 0 potential due to it. So, 10 volt potential will be available at positive plate which is directly connected to terminal A. So, the potential of terminal A, VA, that we can write, that will become 10 volt due to it. Now, at terminal B, potential will be different from terminal A potential, since between A and B we have this 1 ohm resistance. So, with the passage of current through this, some voltage drop will take place. That is why potential of terminal B will be different from terminal A. Similarly, terminal C potential will be different from terminal B, since again there is a resistance between B and C. So, voltage drop will be there with current flow in branch BC. But potential of C and D, they will be equal, since between C and D again there is no resistance, only a simple wire is there which is having almost 0 resistance or negligible resistance. That is why there will be no voltage drop with the flow of current in this path CD. So, that is why VC will be equal to VD. So, now after seeing this circuit, what we see here now, we have two unknown potentials B and potential at node B and potential at node C. Basically, what is node? That we know. Node means a junction point where 2 or more than 2 branches are joining, that is node. So, like here we see at this node B, there are 3 branches, one is this branch, another one is this branch and third one is this branch. These 3 branches are meeting together at junction point B or node. Similarly, at node C, there are 3 branches, 1, 2 and 3. These 3 branches are joining at point C or node C or junction point, whatever we call it. So now since VB and VC, they are unknown in this circuit. So we are to find this VB and VC with the help of node voltage analysis. So what we do for this, as we have discussed in the previous slide also, we will write KCL equations on these nodes or junction point B and C. And for that, what we do, we assume currents in the different branches which are meeting at these nodes. Those currents will be unknown values currents, and that can be taken in random orientation, or that means random directions. So suppose I take outgoing current from this node B in branch AB. This is suppose I1. Similarly, in this 5 ohm branch, suppose current is I2, outgoing current from node B. And similarly, in BC branch, suppose I take outgoing current I3. So the KCL equation as per that will be I1 plus I2 plus I3 equal to 0. Since all these three currents we have taken outgoing current from this node B, and there is no incoming current to this node B, so the sum of I1, I2 and I3 will be 0. Now, what is I1, I2 and I3? That can also be written. We know current is given by voltage upon resistance in any branch. So I1 current, since it is going from B to A, that we have assumed. So first we will write potential of terminal B, then minus potential of terminal A divided by resistance in this branch 1 ohm, and this can be written VB minus 10 upon 1. Similarly, current I2 we have assumed current in this branch BG from B to G. So first we will write the potential of terminal B, since it is taken from B to G, current I2, then minus VG upon resistance in this branch, which is 5 ohm. Now this can be written VB minus 0 upon 5, since the potential of terminal G is 0. Similarly, I3 current, that can be written I3 will be VB minus VC upon 2. So we can put the values of I1, I2 and I3 in this equation, which is KCL equation at node B. This is equation number 1, suppose. Similarly, at node C, we will write KCL equation again. So at node C again, suppose we assume outgoing current from node C in this branch CF, that is like this. This is suppose I4. So I4 will be VC minus VF upon 10 as per earlier method. And the potential of F is 0, since it is connected to ground node directly. So this is VC minus 0 upon 10. So that way we write this current I4. And now the KCL equation at this node C or junction point C, that will be written as 2 plus I3 equal to I4. This is KCL equation at node C. How we write this equation? We can see here this 2 ampere current that is entering to this node C, while this I3 is also entering to this node C, and I4 is outgoing current, leaving current from node C. So entering current equal to leaving current. That's why 2 plus I3 equal to I4. This becomes equation number 2. And this is KCL equation at node B. So that way we have these two equations in terms of currents of different branches, and these equations are KCL equations of at node B and node C. And we have written the expression for I1, I2, I3 and I4 also. So now from this, if we see, we have two unknowns VB and VC finally, and we have two equations also. So by solving these equations, we will be able to find the node potentials B and C. And once we are able to find the node potentials B and C, then we will be able to find the current in any branch of this given circuit. Like in 2 ohm branch, suppose we want to find the current. So the current will be given by VB minus VC by 2 in the direction B to C. Or if you want to find it in C to B direction, so that will become VC minus VB by 2. So that way we are able to find current in any branch, and from that we can also find power in the branch. Like in 2 ohm branch, the power will be current in 2 ohm branch square into 2 ohm. That will be the power in 2 ohm branch, since power is given by I square R. So this is the procedure to find this. So now if we see it, the same question that we have solved in the previous slide. So this is shown here. We are taking node potential V1 and V2 here. There we have taken VA and VB, not V1, V2, the VB and VC. So here we are taking V1 and V2 in place of VB and VC. And this is ground node, as already we have discussed. This is 10 volt potential at this node. And similarly, the equations now, V1 minus 10 by 1. This is this current, V1 minus 10 by 1, outgoing current from V1. Similarly, V1 by 5, that is this current, outgoing current from V1 in 5 ohm branch, and V1 minus V2 by 2, that is this current leaving this node, and it is equal to 0, since all these 3 currents, they are leaving the node and no incoming current to the node, that's why it is 0. This is equation number 1. Now, another equation at node 2, that where the potential is V2. So, V2 minus V1 by 2, that is now this current, this is V2 minus V1 by 2. This is V2 by 10, this current, and 2 ampere is incoming current, or we can say minus 2 ampere is outgoing current. So that's why we can write this equation. This is equation number 2. All these 3 currents we have taken outgoing current, and the sum of the outgoing currents equal to incoming current, but no incoming current we are taking here. So that's why it is 0. So now on solving these equations, we find the value of V1 and V2. V1 is coming as 100 by 11, that is 9.09 volt, and V2 is coming as 120 by 11, that is coming at 10.91 volt. So that way we find both V1 and V2 potentials of these nodes, and once we know the values of these potentials V1 and V2, we can find the current in any branch of this circuit. Another thing we can see from here, the important information, V2 is at higher potential from V1. So the current in 2 ohm branch will be from V2 to V1, since current flows from higher potential to lower potential terminal. So that way we can find the current in different branches, and if you want to find the power in 2 ohm branch, so that power will be current square into 2 ohm, and current means the current in 2 ohm branch. So that will be power in 2 ohm branch, since power is given by I square R. Another example, if we see, like in this circuit, this we have taken ground node here. This is ground node or reference node or datum node, and with respect to that, the different node potentials we are to take. So this will be 100 volt potential. See this 100 volt battery that is connected between this terminal and this terminal, this one and this one, and negative plate of this battery is connected directly to this terminal, which is connected to ground node. So it will be at 0 potential due to it. So 100 volt potential will be available with positive plate of this battery, which is directly connected to this terminal. So this potential will become 100 volt due to it. Now this potential is suppose V1 at this node, it is V2 suppose. Now V1 will be 100 volt directly. Reason being, there is no resistance between V1 and 100 volt terminals, so that voltage drop will not be there due to a simple wire connected between V1 and 100 volt potential terminals. So no voltage drop, and that's why V1 will be equal to 100 volt directly. So there is only one unknown, this is V2, which we are to find in this circuit. So we will write KCL equation for this. So suppose we assume currents in this branch like this, here in this, and this is 5 ampere incoming current. Or if we take outgoing current, so this will be minus 5 ampere. So the equation will become V2 minus V1 by 10, that is this current, 10 ohm branch current. Similarly, V2 by 50, that is this current in 50 ohm branch current, and minus 5, that is equal to 0, since all these 3 currents that we have taken outgoing currents, and the sum of these 3 will be equal to 0, since there is no incoming current at this node we have taken. So, and on solving these equations, this equation basically we get V2 equal to 125 volt. V1 already we know 100 volt. So we know both the potentials V1 and V2, and now we can find the current in any branch of the circuit with the help of it. Like if I want to find the current in 50 ohm branch, so that current will be simply V2 by 50, or this will become 125 upon 50 ampere in this direction. And if you want to find the power in this 50 ohm branch, that will be given by current square into 50, where current is in 50 ohm branch we are to take. So that way we solve any circuit using this node voltage analysis. Another example we can see, like in this circuit, we are to find the current through 4 ohm resistance in this circuit. That we are to calculate. This is 3 ohm. This is 6 volt battery with positive terminal and negative terminal. This is 4 ohm. This is 5 ohm. This is 7 ampere current source. This is 2 ampere current source. So now what we do, once we assume this ground node here, suppose, since in this bottom line all the terminals will be having same potential, again due to the region there is simply wire connected in this bottom line, so there is no potential drop or voltage drop in this line. That's why all the terminals in this bottom line will be at same potential. So we assume ground node here, and with respect to it, the other nodes like this potential VA we assume here. Here it is VB suppose, and this is VC. So there are 3 unknowns. So now we write equation. We will convert it to 2 unknowns. How do we convert? Like this 6 volt battery, this is connected between node A and B, and with positive plate of 6 volt is connected with A and negative plate connected with B. So we can write the equation VA minus VB equal to 6 volt. That is one equation. Another equation, suppose I assume current in 3 ohm like this. In 4 ohm, this is current suppose I2. In 5 ohm, this is current I3 suppose. So at node A, the KCL equation will be two equal to I1 plus I2. Since this 2 ampere current that is entering to this node, while I1 and I2 they are leaving this node. So 2 will be equal to I1 plus I2, since as per KCL, incoming current equal to outgoing current at a node. So this is equation number 2. Similarly at node C, I2 current is entering, I3 current is leaving, and 7 ampere is also leaving. This is equation number 3. So these are the KCL equations at node A and C. At node C, I2 is entering current, I3 and 7 ampere are leaving current. So that this is the equation. Now we are to write the values of I1, I2 and I3 also. Then we will solve the equations. So I1 current, that will be equal to, I1 current is passing through 3 ohm branch that we have assumed from terminal A to E. So I1 current will be given by voltage upon resistance. So voltage, first node A potential we will write VA, then minus VE, since the direction of current is from A to E, divided by resistance of this branch 3, and this will be equal to VA minus 0 upon 3, since the potential of E is 0, since it is at ground potential in the bottom line connected with ground node. This is ground node or reference node or datum node. Similarly, current I2. I2 will be given by VB minus VC upon 4. Since this current is in this branch BC and direction is B to C. So first we will write potential of B, that is VB, minus potential of C, that is VC, divided by resistance in this branch, that is 4 ohm. So this is VB minus VC by 4, this way. Similarly, current I3, which is passing in 5 ohm resistance, this. So I3 will be given by VC minus VD divided by 5, and this will be equal to VC minus 0 upon 5, since the potential of D is 0. It is again connected directly to the ground node. So these are the current I1, I2, I3 expressions, and now we put these expressions here in these equations. Now one more thing which is important here, we are to take two variables only, that is VA and VC. So we are to eliminate VB also. So how do we eliminate here? In I2 we will eliminate VB. I2 current will be written as VB minus VC by 4, that can be written as VA minus 6 minus VC upon 4, since VB is VA minus 6 from equation number 1. So that value of VB we are putting here VA minus 6. This is the value of VB. So now this I2 is coming in terms of VA and VC. I3 also in terms of VC, and other than that I1, that is in terms of VA. So now these equations that will be having two variables only, that is VA and VC, and there are two equations, one is this equation, another is this equation. So on solving these equations we will come to know the values of VA and VC, that we will find. And once we know the values of these VA and VC, we can find the current in any branch. Like in this question, it is asked to find the current through 4 ohm resistance, that is to be found. So in 4 ohm resistance, this current will be given by this relation. This is current I2, VA minus 6 minus VC by 4. VA and VC we have calculated already by solving the equations. So put the values of VA and VC here in this expression, we will be able to find this current I2, which is the current in 4 ohm branch, this current. So that way we solve these circuits using nodal analysis method. Further, another example, that is we come now for the super node. This is the problem of super node. So first thing is we should be clear what is meant by super node. Super node means when a voltage source is connected between two non-reference nodes, that is known as super node. You can say it. So like in this circuit we see, here we have assumed this reference node, this one, and this node and this node, where the node potentials are V1 and V2. Between these two nodes, this 5 volt voltage source is connected. No other element is there. So this V1 and V2, these are two non-reference node. V1, this is non-reference node, and V2 is also non-reference node. And in between these two non-reference nodes, one voltage source is connected. So that's why this becomes the problem of super node. So now we are to solve this circuit using this nodal analysis method. So what we do, again we apply KCL at different nodes where we are to find node potentials. So we will apply KCL at this node where the node potential is V1, which is unknown for us. Similarly, at this node where the node potential is V2, which is also again unknown for us. So at V1, this 4 ampere current, that is incoming current. This is suppose outgoing current we are taking. Suppose here this current, we assume it is suppose I current, and in this 1/3 ohm, suppose we take this current like this. So now the equation will be 4 equal to this -4 we are taking, we are assuming 4 ampere as outgoing current, that's why we can write -4. Since 4 ampere is incoming, so -4 ampere is outgoing. So -4 outgoing current, then V1 upon 1/2, that is outgoing current, this current, then V1 minus V2 upon 1/3, that is again outgoing current, this current, and this current is suppose I, this current is I, this one that we assume, and this is equal to 0 since all these 4 currents which are leaving this node, we have taken as outgoing currents. So, sum of all the outgoing currents will be equal to incoming current from this node, but there is no incoming current we have taken at this node. So, that is why it is equal to 0. This is equation number 1, suppose. Now, another equation, KCL equation at this node 2, where node potential is V2. So, what will be the equation? This equation will be, suppose I, we are taking outgoing current from here. So, this will be now minus I. Since I taken, we have taken in this direction. So, minus I will be in opposite direction. In 1/6 ohm, this is this current, leaving current suppose, and this current in 1/3 ohm, this is incoming current. So, outgoing current can also be taken from here, and this 9 ampere is incoming current. So, outgoing current will be minus 9 ampere. So, the equation will be V2 minus V1 by 1/3, that is this current we have taken here, V2 minus V1 upon 1/3, we are taking in this direction this current, plus V2 upon 1/6, that is this current, this one, minus 9 ampere that we have already seen here, this we have taken outgoing current minus 9 ampere, that is this, and minus I that we have taken here in this direction, leaving current. So, this is this. So, this is equation, that means all these 4 currents which are leaving from this node, and the sum of these currents will be equal to 0 since there is no incoming current to this node that we have taken. So, this is equation number 2. Now, since this current I, we cannot find this current, reason being there is no resistance connected in this branch, and this V1 and V2 they are forming super node. Reason we know, since this V1 and V2 they are non-reference node, and in between this a voltage source of 5 volt is connected between these 2 nodes, non-reference node, that is why it is super node. So, what we do now, we eliminate this current I from equation number 1 and 2, since we are not able to find this current I due to the reason there is no resistance in this branch. In this branch there is no resistance. So, on elimination of this current I from this equation 1 and 2, combined equation comes out as this. This is equation number 3, suppose. On elimination of I, now in this equation there is no current I, and how do we eliminate I? By, if we add these 2 equations, I will be cancelled out, since here it is plus I and here it is minus I. So, on adding these 2 equations, this is the final equation that we can see. Now, we require 2 equations to solve this circuit, since we have 2 unknowns V1 and V2. So, this is equation, one of the equation that we get out of these 2. Now, we require one more equation still to solve this circuit. So, how can we write that equation? If we see this 5 volt voltage source, this positive plate of this 5 volt voltage source that is directly connected to this terminal, and it is the potential V1 here, and negative plate of this battery or voltage source that is connected directly to this terminal where the potential is V2. So, we can write V1 minus V2 equal to 5 volt. This is equation number 4. So, now this is the another equation for V1 and V2. So, now with the help of equation number 3 and equation number 4, we can solve these 2 equations, and we are having 2 unknowns V1 and V2. So, by solving these 2 equations, we will be able to find the values of V1 and V2. And once we know the values of V1 and V2, we will be able to find current in any branch of this given circuit. So, this is the method for solving super node problem or super node analysis in a given circuit. So, that way, by using nodal analysis, we can apply it to a simple circuit, or it can be applied in case of super node problem, and from this we will be able to find the node potentials, unknown node potentials, and then the currents in different branches, and if we are to find power also in the branch, that can also be found. So, that is all about this discussion. In this, we have learned that how to apply nodal analysis using KCL at different nodes, how to write the equations on those nodes with the help of KCL, and then to solve those equations in order to find node potentials, and then the currents in different branches and power in the any branch which is required. So, that is all about this discussion. In the next discussion, we will be discussing another topic from the syllabus. Thank you.